Hello everyone, welcome back to the session, and in today's class again we are going to see few concepts from motion in a plane. So before I go ahead, my name is Mohana. I'm a physics educator here at Unacademy. So if you're taking your class 11 and 12, I'll be teaching. Now this is my Telegram channel link. So before any class could go live, any updates are there, it will be shared here. Similarly, this is the class, this link is for the common Telegram channel, that is ICSE and ISC both channels. So you can follow this channel as well. Okay, now just like how we have the YouTube sessions, right, we also have the some free classes on the Unacademy platform, and those we call it as special classes. Now these special classes are absolutely free. You can take any of your favorite educators classes and you can engage with educators via pool feature. So you can check out how this feature is. Like, you can actually have an interactive class while actually answering questions. Okay, and since these special classes are also live classes, if you have any doubts, you can get them cleared now, then and there. Now, if you go to the link in the description box, the upcoming special classes for the for this week, right, the upcoming week, whatever special classes are there, and also in the next month what special classes are there would be given. So you just click on the link that says class 11. It will take you to that link. Okay, and there actually you can just click on notify button. So before any course could go live, you will be notified as well. Okay, now the upcoming special classes, the next class we have is tomorrow, that is 29 June at 4 p.m. all right, and this class is again a free class. So till now, in the past two classes and including this class as well in a YouTube channel, we have been learning about vectors, right? So tomorrow's class we will learn about applications of vector. Okay, and this is going to be part 2 in the series. All right, so today we will learn about analytical methods of vectors. Okay, and whatever we are learning today, we will apply those. We will see the practical applications of those vectors in the in the upcoming class. Okay, that is tomorrow's class, and I'm hoping to see all of you at 4 p.m. tomorrow. Now, next month classes, that's free classes that I have, that I would share them in the Telegram channel, and in the upcoming classes I would definitely share the YouTube classes. I would definitely share what are the special classes that we have as well. Okay, and if you just go to the description description link there, you would be able to see the upcoming special classes for the next month as well. So the next class, which basically we are going to do after this applications to vector in the Unacademy app, we will be solving numericals, especially from dimensional analysis. All right, you can check out that class as well. Now, if you're interested in the plus subscription, then there are certain benefits. One is you can learn from the comfort of your home, and then you will have access to unlimited courses. Meaning, if in case you're taking the plus subscription with Unacademy, you're just getting one subscription. Whatever amount you're paying, you are getting 4 classes. That is, getting 4 subjects. That is physics, chemistry, math, and biology. All right, you're getting 4 subjects, and you will get unlimited access to all of these 4 courses, and all the educators on the academy are nice, so you will be learning from the top educators. Then in a plus class, every 4th session is a doubt clearing session. Okay, so let's say the class starts today, a course starts today. Okay, every 4th session is always a doubt clearing session. Whatever doubts you have in the previous 3 courses, we can do it in this, you can ask in this doubt clearing session. In case you had missed any of the previous classes, and if you have seen the class recordings, and if you still have doubts, you can ask during this class recording doubt sessions as well. Okay, and in the plus class we will cover your entire syllabus. Okay, and you will get access to practice test, and also you will get every other week there will be a live test series that happens. So after the live test series, there will be an analysis session where the educator would show you the proper ways of solving the questions that you would have attempted. Okay, and in case you've got any mistakes, you can clear any of your misconception you have over there, or in case if you want to know how to solve a problem in a particular easier way, you can ask that as well. So we are coming up with new batches, and I'll tell you those details in a moment now. And with Unacademy, if you see, the longer duration course you take, the price per month goes down. Okay, now before we come across to the price, let me quickly tell you there is an ongoing batch that is going for class 11. Don't worry, it started on 8th June and the mode of delivery is going to be in English, right? And for physics, we meet every Tuesday, Wednesday, Saturday between 5:15 to 6:15 p.m. Okay, and for all the missed classes, you can see the class recordings will be provided. You can see the class recordings, and then during the during the doubt classes, if you have any doubts, you can ask. And whenever you're taking a plus subscription with Unacademy, you are getting 4 subjects, and for each of the subject in a month, there will be a minimum of 10 classes at least. Okay, so in a month, there will be a minimum of 40 classes per month, minimum of 40 classes. Okay, and if you're in class 11, you're in an advantage. You can take a class 11 subscription, and class 12 subscription is absolutely free for you guys. Now, other than this, I have one more important announcement as well. Right now, we are giving a 20% offer. Okay, so till now you've been getting to a 10%, but now we have a 20% offer. Meaning, if you're planning to take a plus subscription, and you can use my code MTIS10 to get a 20% offer. So this offer is valid only between 27th to 30th June. Okay, so if in case you're taking a subscription plan for 1 year or more. Okay, so if you're taking 1 year subscription, you're paying 13,800 and you're saving 3,450 rupees. Okay, and if you're taking a 2-year subscription, you can see that you're saving around 5,750 rupees and you're paying only 23,000. And since you're in class 11, if you take 1 year subscription, class 12 subscription is absolutely free. So you're paying for 1 year, right? And you're getting 2 years benefit. And in a month, you have minimum 40 classes for physics, chemistry, math, and biology. So if you see the price as of now that you have, if you see the price per class goes down up to 20 rupees as well. Okay, within 20 to 30 rupees is the amount you're paying per class, right? This is the lowest the price can get. So if in case you're planning to take this plus subscription, now would be the great time. Now with that note, last class we already started concepts from motion in a plane. If you have any doubts about it, about any of the concepts we discussed in the last class, you can ask me. Otherwise we will start with today's class, right? So we learned about scalar quantities and vector quantities. So scalar quantities, they have magnitude, right? And they change only in magnitude and they are added using the ordinary law of algebra. But then if you take vector quantities, they have magnitude and direction. So they can change if magnitude changes, direction changes, or both changes, and they can only be added using special laws of vector addition. Now, whenever you represent the vector, the length of the vectors is talks about the magnitude, right? And the direction arrowhead over here points towards which direction the vector is going on, right? Going towards. Now, we also learned about what is a position vector and a displacement vector, and we learned what are the 2 types of vector. One is polar vector. Polar vector means something like velocity, force, all of this comes under polar vector. But when you talk about axial vector, okay, and rotational, we are basically talking about rotational motion. Then comes in this case, we are talking about your angular velocity or force. Sorry, angular velocity or torque, alright. So these are the 2 types of vector. We covered this also. And we saw what were equal vectors. They are equal in magnitude and going in the same direction. When you're talking about negative of a vector, it means the magnitude wise or the length are the same, but the directions are different. Then we saw modulus of a vector. Modulus of a vector gives you the magnitude of a vector. So modulus of a vector is always, yesterday also emphasized this point, modulus of a vector is always a scalar quantity. Alright, okay. Now, a vector, unit vector is very simple. Unit vector will be in the direction of the vector itself. But if you take a vector and if you can make that vector up with let's say you have a vector, right? It's going in this direction. Now, if you can represent this vector as unit vectors, where each of the small one has a magnitude of 1, okay, then we can say we can represent this vector as a unit vector, right? And we also saw that unit vectors, we can actually give a unit vector as right, you can actually give a unit vector when you're talking about a unit vector as the vector by its modulus, right? The vector by its modulus, it's nothing but it just gives the scalar. Okay, so this a vector can be represented as the scalar or the magnitude into the unit vector. Okay, so this is your unit vectors. We have seen this in the previous class as well. Then we saw what is fixed vectors and what is non-localized vectors. And in collinear vectors, these are of two types. One is parallel vector, another one is anti-parallel vector. We have seen this as well, right? And parallel vector means their theta angle direction is zeros, which means they're going in the same direction. Okay, anti-parallel or unlike vectors means same magnitude but they go in different direction. Okay, and coplanar vector means vectors in the same plane. Co-initial vector means the starting point of the vector, the tail of the vector, right? If there are 2 or 3 vectors, their tail of the vector starts in the single point. Okay, coterminus vector means all of the head will actually, the coterminus is the arrow point is at the same point. Okay, now we also saw when there is 2 vectors acting on a single object, right, then the result produced. If it is produced by one single vector, then we call that as a resultant vector. Okay, now the process of adding 2 or more vectors is called composition of vectors. So according to law of vector addition, we have triangular law of vector, parallelogram. So triangular law and parallelogram law of vectors, we can add only up to 2 vectors. But polygonal law of vectors, using that we can add up to 3 or 4 vectors. Okay. Alright, now let's say triangular laws of vectors. Before we learn a little bit more about it, we already saw this in the last class. For example, let's say there is an object here. Okay, now let's say and a force is being applied to it, okay, in this direction, and because of the velocity that it applied, the object moves here. Okay, then one more force is being applied, but in this case it's in this direction. So this is the initial point or the starting point, right? This is the final point of the vector. Now if you want to find what is triangular laws of vector, right? So you take this vector, let's say this is A vector and this is B vector, right? You have A vector, okay, and B vector. In this case, what are we seeing? We are seeing that the tail of the vector, see, the tail of the vector over here starts from the tail of the vector starts from the head of this vector, right? So if these 2 sides are acting like 2 sides of a triangle, right, the resultant, the combined effect of these two vectors is just given by the other side of the triangle, that is from the starting initial point to the final point. Now this is the resultant vector, which is equal to A vector plus B vector. Why? Because vector can only be added geometrically. Okay, so this is the direction of your vector. Now the next is parallelogram law of vector. Okay, here let's say you have 2 vectors. Let's say you are applying a force to this object and it's going in this direction. Okay, let's say one force is applied in this direction and let's say another force is applied in this direction to the same object, right? Then what will be the resultant of these 2 forces? Okay, one is going in this direction, another is going in this direction. What will be the resultant effect that is acting on this direction? This is A vector, this is B vector. To understand what is the resultant effect, we have to consider this as a shape of a parallelogram. Alright, this resultant, again parallelogram law of vectors will only let you add up to 2 vectors. Okay, the resultant would be along the diagonal of this parallelogram. See here, this is a co-initial vector. All 3 vectors are starting at the same point. Okay, here R vector will be equal to A vector plus B vector. Okay, now polygon law of vectors means you can add more than 2 vectors. Okay, let's say on an object there is a particular vector. Okay, let's say the velocity, let's say different velocities are given to an object. Okay, one velocity is given in this direction, let's call it as A vector. Let's say one velocity is given in this vector, so this side B vector. Let's say one is given in this side C vector, and let's say one given is actually this way, this is D vector. Okay, these are the 4 velocities acting. Now how do we add this using the polygonal law of vector addition? Very simple. Okay, so this side, this is the starting point from here to here. Okay, this is your A vector. Now the second velocity that was applied, you start from this head over here to the tail of this vector. You start from the head of the previous vector, okay, till you so this would give you the B vector. It's in this direction, right? Now C vector, if you see, it is again starting from this vector over here and it's acting in this direction. So this is C vector. right? Now, d vector, if you see d vector over here, let's say this d vector is actually acting not in this direction. Let's say the d vector is actually acting in this direction, right? Now, from here, the d vector is acting down in this direction. Now, what these three, all these four on one particular object, four velocities were acting, and they were acting at the magnitude was different, the direction was different. Now, the resultant of all these four, okay, you can actually find that geometrically using polygonal law of vector. Now, the resultant vector will be from the initial point A, the tail of the A vector, to the head of this final D vector over here. This will be your resultant, and your resultant R vector would be a sum of A vector plus B vector plus C vector plus D vector, meaning whatever these four vectors sum could produce, that is produced by the resultant vector R. So these four vectors, okay, effect can be replaced by this one vector, which is your resultant vector. Alright, now the next one is last class we also saw that if you have any doubts, you can again ask me in the comment box, right? We saw that vector addition, last class we saw vector addition was vector addition is associative, right? Sorry, is commutative. This is what we saw. Last class we saw vector addition is commutative. Meaning, okay, A vector plus B vector gives you C vector plus D vector, right? So, sorry, I'm really sorry. This vector would be equal to B vector plus A vector, right? This is what we saw. Meaning, let's say there are two vectors. Let's say this is B vector and let's say this is A vector, okay? The resultant will be in this case, because both of them are starting from the, it's a co-initial vector. See, both of them are starting from the initial point, or the tail is together, right? In this case, you will use parallelogram law of vectors for addition, not triangle, okay? When you talk about triangle or polygonal law of addition, you can see that the tail, the second vector, that the next vector you're adding will start from the head of the previous vector, okay? Now, this actually gives you your resultant vector. Now, if you see this length over here, because it's a polygon, these two sides are equal and these two sides are equal. So, this length, whatever is it, is equal to this length over here, right? So, if you give a name like, let's say O, let's say OP, S and R, let's say these are the four sides of a polygon, okay? Now, you can actually say, now R we are using for resultant, so let me just replace that with Q, okay? Now, if you see this side, OP is parallel to QS, also OP is equal to QS, right? So, from here you can actually see, okay, from here you can actually say this QP, right? And yeah, you can actually, from here you can say that these two sides are equal to A vector, right? Right. Now we saw that QP, right, plus QO gave us this R vector, right? Likewise, we can also see that this vector OB, that is OQ, right, plus QR, right? If you take this OQ side plus this QS side, that also gives you, this also gives you this. Again, if you see only a component of this, you can see this looks like a parallelogram, right? So this, from here, from head to tail, there is a vector. From the tail, there is another vector starting. The resultant of that from the initial to the final part. Okay, again, this is like a parallelogram, right? So the resultant effect is produced by this vector. Alright, so from resultant effect, if you're seeing, this is equal to OS vector. Now this vector is actually B vector plus A vector is equal to OS vector, right? And on another end, you can also see this is equal to OS vector. On another end, you can also see this side, right? This OP, right? OP vector plus, right, OQ vector, right? This side, OQ vector actually gave you, or OP vector plus this PS vector, since these two vectors are same, right? Because we started with this side, right? Okay, we started with adding this, right? A vector from B vector, this A vector plus B vector, A vector plus B vector, that is these two sides was equal to this OS vector. So from here we can say we started with A vector plus B vector, and finally these two quantities are equal, means this A vector plus B vector is equal to B vector plus A vector. This gives you the vector addition is commutative. Okay, meaning you can shift vectors. So if rather than having it here, you can shift this vector here and it still give you the same thing. So this side and this side has the same magnitude. Okay, and they are parallel to each other as well. Similarly, this side and this side, they have the same magnitude and parallel to each other. Okay, so if I move this B vector to this side, it will still give you the same effect. Okay, that says about the vector addition is commutative. Now the next one is actually vector addition, right, is also associative. Okay, now what do you mean by vector addition is associative is, let's say you have a vector over here. Okay, we're going to take a polygon. Okay, let's say I have one vector, this is A vector. Let's say this is OP of a polygon. Okay, let's say there is another side that is PQ of a polygon, and that side we are keeping a vector B vector. Okay, let's say there is another side of the polygon which is basically QS, and let's say this is C vector. Now adding all these three vectors, we are actually getting a final vector, that is from starting the initial point ending in the final vector, final point over here. So this is basically your resultant R vector. Okay, now we're going to use some triangular laws of vector addition to prove in a polygon that vector addition is actually associative. Okay, so what we will do, we will actually resolve this. This is the start of a vector and I'm able to see there is the end of the vector, right? These two vectors we can draw a diagonal, and towards this side we can actually draw a diagonal. Okay, so here if you see, here if you actually see, right, you're able to see in this case, okay, in triangle OP and Q, okay, you take this triangle, we are able to see that this side OQ, right, this side OQ, right, that ends over here, right, OQ, right, this is equal to OP vector plus PQ vector. Okay, this side over here is equal to this vector plus this vector, right, which means OP over here is A vector, right, plus B vector. Okay, now similarly if you see the triangle, if you see in the triangle OQS, okay, if you see in the triangle OQS, in this triangle over here, you can actually say this OS vector, okay, this OS vector over here, okay, now we are considering this part of the triangle. Okay, so this one OS vector over here will be equal to OQ vector, right, plus QS vector, right. This, in this part of the triangle, this vector, this is from the initial to the final point, right, this vector is equal to this vector PQS. Okay, we are going to consider the triangle PQS, this triangle. Okay, now if you see, this is the starting point to it ends here, and then over here from there the other vector starts and ends here. So here if you see, this is the starting point, this is the ending point, right. So the vector starts here at this point and ends in this point, right. This vector is in this direction. Okay, so here if you see, okay, the final side is what? Final side over here is PS, right. This PS vector is nothing but PQ vector plus, okay, QS vector. So this PQ vector, that's PS vector that I'm seeing, this vector over here, this vector over here will be an addition of this vector plus this vector, right. So once this side is actually B vector, and the other side is actually C vector, right? So we have considered one thing, right? Now this side over here is basically B vector plus C vector, right? Now let's consider one more triangle, that is O, P and S. Okay, we're going to consider O, P and S. Okay, this time we're going to consider O, P and S, this triangle. Okay, so in this triangle over here, if you take this OP vector, right, plus this PQ vector is equal to OS vector, right? So let's do that. Let's say OS vector over here. Okay, this is starting point and this is where it is ending, right? This OS vector is equal to OP vector plus PS vector over here. Okay, and OP vector was basically this vector. OP vector is A vector, and PS vector is actually, we just found that to be B vector plus C vector, right? So this is OS vector, right? Now we have the second equation. Now from equation 1 and 2 we can actually say over here, from the equation 1 we have A vector plus B vector plus C vector, which is equal to, in the equation 2 over here we are able to see, right, this is A vector plus B vector plus C vector, right? From here we can say that vector addition is associative. So there were two properties. So one is vector addition is commutative, and as well as vector addition is associative as well. Okay, now let's do some analytical method of vector addition so that it is useful for the upcoming next class. Okay, so we will learn about the analytical method here, and in the next class tomorrow at 4 p.m. we will see some practical applications of vector. Okay, so that's our goal today. So if you have any doubts, once again you can ask me in the chat box as well. Okay, and just give me 1 second, guys. Alright, so now we are going to do we're going to do let's do analytical method of vector addition. Okay, first we will do this method for the triangular law of vectors. Okay, first we'll do this for the triangle law of vectors. All right, now we're going to, very simple, let's say we have a vector, right? So you're going to have a vector, right, which is of the side OP. Okay, let's say that is OP, one side of the triangle. Okay, now there's another side to the triangle, okay, and that be OQ, and this OQ side, okay, on this side of the triangle we have the B vector. Okay, this side of the triangle we are actually having the B vector. Okay, now according to triangular law of vector addition, right, your resultant vector that you're going to get will start from the initial point and end in the final. Okay, so it starts from the head, tail over here, it's tail, it starts from the initial point and head has to go reach in the final point. Well, this is your final side. So this is actually your R vector, which is nothing but A vector plus B vector, right? This is your triangular laws of addition. So basically you have two sides of the triangle, there are two vectors, and the third side gives you the effect of these two vectors. When it's combined, whatever effect you're getting, that you will get it by the third vector. Right, now from here, okay, what we're going to do from this QN over here, from this point Q over here, right, before that let's also do one more point. Okay, let this be B vector. Okay, from this point Q over here, we are going to drop a perpendicular to ON. Okay, now this is perpendicular to ON over here. Okay, and let me name this as N, and this over here is around 90 degrees, and this gives you an angle theta. Okay, now if you see that the triangle, in the triangle we are going to check QPN, in the triangle QPN. Okay, this has an angle of theta. Okay, and we also know this OP is equal to A vector, we just saw that, right? And PQ is actually equal to B vector, right? Or it's equal to the side B. Okay, and we can also see that OQ actually gives you the resultant R. Okay, this actually gives you the resultant R as well. Okay, this is actually all of these values are known. OP is equal to A, right? And also we know that PQ, this side is equal to B. Okay, magnitude of B, this side is equal to the magnitude of B, and this arrowheads point towards its direction, right? And if you take the final one, we know this OQ is equal to R. Okay, now this OPN, if you take this Q, P and N, okay, this Q and P, this is actually a right angle triangle, right? This part is actually a right angle triangle. Okay, so from here we can get different angles. One is, you can see the from here you can actually see QN, right? You can say that QN, right? You can actually say this QN and this side, right? This side QN by, okay, by PQ. Okay, QN by PQ means this is the angle over here. So you have your perpendicular with hypotenuse. So perpendicular by hypotenuse actually gives you sine theta. Okay, or from here you can take your QN is nothing but PN into sine theta. Right? So QN over here, the value QN over here, PN is what? PN in this case, okay, is actually has a magnitude of B. Okay, so this PN over here, okay, sorry, this is equal to PQ. I forgot this is, I made a mistake. This is not QN. Okay, QN by PQ into PQ. Okay, PQ. The value of PQ is B. So QN is B sine theta. So this particular QN, this has a value of B sine theta. Okay. Now we're going to consider, this is for the angle theta over here that we consider. This is B sine theta. Right? If you still have any questions, just ask me in the chat box. Okay. This is very simple. Right? This is actually QN and this is actually PQ. We have taken this angle. This perpendicular by hypotenuse gave us sine theta. So QN is what? This side QN will be what? PQ into sine theta. And PQ is nothing but B. That side has a magnitude of B. Okay. Now similarly, let's consider one more angle. Now we took PQ, right? Now this time let's try PN. PN by PQ. Now this is actually base by hypotenuse. What is base by hypotenuse? Base by hypotenuse is actually cos theta. Right? Or you can say this PN is equal to PQ cos theta. So PQ over here, right, is nothing but, again, PQ over here, this side has a length of, see, this side has a length of B, and you get B cos theta. So this downside over here that you're seeing, I'm really sorry, just give me a moment. I'm really sorry about that, just give me a second. Okay, now this side length over here that you're seeing, okay, this will be P sine theta. That is this PN. So we have a triangle here. Okay, let me do that separately. This is PN, okay, and this side is actually Q, and this side is B vector. Okay, now if you see, if this B vector, if you could resolve it into your horizontal and vertical component, this side horizontal component is actually your B cos theta, right? Let me do that once more. This horizontal component is actually your B cos theta, and this vertical component is your B sin theta. Okay, so you have actually resolved this vector into two components. Okay, so you've resolved this particular vector into two components. That is, let's say you have a vector B vector. You can resolve it into two components. One is, this side we saw was B cos theta, and this side we saw was B sin theta. Now, since according to parallelogram law of vectors, since you can move these vectors, right? So we can say that if you have a resultant vector B vector acting in this direction, right? This could be of two sides. This side would be B cos theta, horizontal or the x direction. This vector over here, you can move it to this side as well. Okay, because according to parallelogram laws of vector, right, two sides are going to be these two sides, right? If I actually draw a parallelogram, right, these two sides are going to be equal. So I can move this side also. This will be B sin theta, this is B cos theta, right? So I can actually do it in this way as well. Okay, now we have done one part, right? According to the analytical method, we have just done one part. Now what we are going to do is, we are going to use the Pythagoras theorem, right, on this triangle. So if you see this triangle QN, if you see the entire length ON and Q, okay, we are going to use the Pythagoras theorem for the same. Okay, so you have O and Q, right, this part over here. So here, first we are going to consider this OQN, this triangle. Okay, so this triangle, using Pythagoras theorem, this OQ, okay, this side, this OQ, this side would be equal to, right, this ON. Okay, this OQ square, let's on the vector, we are talking only about the magnitude in this case, right? This OQ square, this side, is equal to ON square plus QN square, right? Okay, now this ON, you can take it as OP plus PN the whole square, and then you have QN square. Okay, OP is actually, in this case, OP is actually A vector, right? And if you see the other side, okay, and if you're actually seeing the, this is A vector, but PN, this PN is nothing but, we saw this PN is B cos theta, right? So let me just quickly do this. This is A plus B cos theta, the whole square, plus QN is what? QN will be B sin theta, the whole square, right? Now OQ is given by R vector, which is R square. Okay, I'll just solve this alone separately. Alright, so we just saw that R vector, R square, was equal to A plus B cos theta the whole square, okay, plus B sin theta the whole square, right? A plus B, how do we have to split this, right? This will be A square plus B square cos square theta plus 2AB cos theta, right? Similarly, B sin square theta will be B square sin square theta, right? Now these are two common terms we can add, correct? So these two terms we can actually add. So because they have the common factor B, right? So you have A square plus B square, right? So here we have b square cos square theta plus sin square theta. Right? We are just taking the b square commonly out. Okay, in this case we are just taking this b square commonly out. So we have b square cos square theta plus sin square theta. Okay, then you have plus 2ab cos theta. Okay, sin square theta plus cos square theta. If you know the answer, you can actually give it in the chat box. Right? Sin square theta plus cos square theta is nothing but this value, cos square theta plus sin square theta. This value, if you know the answer for it, you can give it in the chat box. So this value is actually equal to 1. Okay, so this value is 1. So we just leave it there because cos square theta plus sin square theta, this value is equal to 1. Okay, plus 2ab cos theta. Okay, from here, this is actually r square. Right? So if you want r is nothing but root of a square plus b square plus 2ab cos theta. So that gives you the magnitude of r. Right? So that gives you, if you want to add, when you're adding these vectors, r vector is equal to a vector plus b vector, right? So if you want to find what is the magnitude of r, you can actually use this method to finally find that the magnitude of r right? You can actually say that the magnitude of this r vector is nothing but root of a square, magnitude of a square plus b square plus 2ab cos theta. Okay, this part being cos theta. Alright. Now what will be the direction? We found the magnitude. Now what will be the direction of r vector? Okay. So let's say this r vector over here, let's say it makes an angle beta. Okay. With the direction of a. Okay, then you have this triangle that is OQN, right? From this triangle, let's say this r vector makes an angle beta with this a vector here. Then we have this right angle triangle ONQ, right? So from this right angle triangle ONQ, this value over here, okay, from this we can actually say, let me just do that again separately. Right, quickly we saw this was your r vector, right? And we wanted to find what was the magnitude of this r vector. And we know this was basically our a vector, right? And this vector was basically b vector. So from the b vector, we actually dropped a diagonal over here. So this point was basically q. And this was n, and this angle over here was theta, and this was p, right? This was again o. Okay, now we said this angle over here, the resultant r, right? The r makes an angle beta in the direction of a, right? Now in the triangle ONQ, because it's a right angle triangle, okay, we can see that if you want the direction of r, okay, this r is because of this vector and this vector, right? Then from here you can actually take this tan theta. We can take tan beta. Tan is what? Tan is given by this vector and this vector, because these two vectors result will produce this effect, right? The resultant of these two vectors, whatever the effect these two are giving, that final vector is given by this direction. So these two vectors gives you this final resultant vector, right? So this vector, the angle it is making, to find the direction of this r vector, right? Let's use this angle tan beta. Okay, this tan beta will give you OP, or we can say that it gives us QN, right? It gives us QN by ON, right? tan theta will give you perpendicular by base. Now perpendicular is fine, but the base ON is nothing but OP plus PN, right? So here tan beta, okay, now this will be basically equal to, right, in this case QN, right, QN, this is nothing but B sin theta, right? QN is B sin theta by OP is actually, the magnitude is actually A, plus PN, this side PN is nothing but B cos theta, okay, PN plus B cos theta. That gives you the angle beta over here. Okay, so with respect to A, this is the angle R makes, and from A, if you trace down that angle, we can actually find what is the direction of R. Alright, so this is the resultant vector for analytical method for vector addition in case of when you're adding two vectors, right, in case of parallelogram. Now in case, instead of this, if you want to do the analytical method for triangular for parallelogram law of vectors, okay, so parallelogram law of means here this will be this vector, okay, let's say there is a side OP, okay, and let's say this OP side is actually A vector, right, and you have another vector, let's say, which is OQ, and this will be B vector, okay. The resultant of these two vectors, right, how do we get that? Okay, so that means I have to take this direction into consideration and also this, right, so the resultant is this one, right, this gives me R vector, which is nothing but A vector plus B vector, okay. The magnitude of this direction and also this is this, whatever this magnitude is, it is the same over here, whatever this magnitude is, it's the same over here, right. So this one will have in this direction, this one will be in this direction, okay. Now from here, okay, we can just draw the perpendicular, right, and let's say I'm taking a perpendicular, okay, let's finish this line, okay. Now here, if you're taking the perpendicular here, this is 90-degree angle, so let's say this point is S, and let's say this point is N, and this one has an angle theta, okay. Now okay, now here you can see the angle, okay, the angle SPN, okay, this will be equal to theta, right, we said this SPN is equal to theta. Similar to this angle that we have over here, we also have, because this is a parallelogram, right, we also have QOP. This angle is theta, means this angle over here, okay, this angle over here is also theta. So angle QOP, both of them is equal to theta, okay. Now the next one is, we can see the sides, okay, we can say the side PS and OQ, right, both are equal to B, the magnitude is equal to B, okay, this one is also B, okay. Similarly OP and QS has a magnitude A, the sides has a magnitude A, and the direction is also given, okay. Now in this case, if you take the right angle triangle, if you just look at the right angle triangle SNP, right, just the right angle triangle SNP, right, this SNP, if you just look at this triangle over here, all right. Now here we can say, this SN by this SN over here by your PS gives you what? This is perpendicular by hypotenuse, right? It will give you sin theta. From here you can say this SN is actually equal to, right, PS sin theta, right? So SN, this side SN is nothing but, this side SN is nothing but PS is B, okay, B sin theta. Alright, similarly if you take this side, that is PN divided by PS, okay, that will be equal to cos theta. if I take this angle with this angle, you'll get cos theta, which implies that Pn will be equal to Ps cos theta, right? What is this Ps over here? Again, this is B. So you get B cos theta, right? So here we can actually say this value over here this length over here is actually B sin theta, and this length over here is B cos theta. Pn is B cos theta. Alright, now we are going to use the, I'm going to erase this and let's start. Okay, now we are going to look at the right angle triangle, but this time we are going to look at the triangle ONS. Okay, we are going to look at the triangle ONS, meaning we are going to look at this triangle ONS. If you look at this particular triangle over here, it's a right angle triangle again, right? First we compared this one. Now if you look at this one, this is a right angle triangle again, right? So from here we can actually say that, right, from here again we can actually say, using Pythagoras theorem, the hypotenuse, right, this hypotenuse, that OS square is equal to the adjacent, right? Adjacent is what? In this case, ON square plus SN square, right? We can say that this side is equal to this vector plus this, right? So from here, OS square is what? OS square over here, we know this is R square, will be equal to ON square. ON square is actually nothing but OP plus PN, the whole square, plus SN square, right? So this is nothing but, this side is nothing but OP plus PN, right? And then we also have this side is SN square, right? So OP over here is what, right? So here we know this R square is equal to OP over here is nothing but A vector, that is A, plus PN over here is B cos theta, the whole square, right? Plus SN is nothing but B sin theta, the whole square. So if we try to expand this, you will have, if you bring this in, this you will have A square plus B square, okay, cos square theta will be equal to plus, okay, B square sin square theta. Okay, and there will also be a term, okay, I missed one more term, that is basically we have A square plus B square plus 2AB, right? This is of the form A plus B. So we know A square plus B square, this A square, this quantity square, and this quantity plus twice of this, right? Product of the twice of it, 2 into A into B cos theta plus B square sin square theta, okay? Again we have A square, right? I'm taking B square commonly out, so I'll have cos square theta plus sin square theta, okay, plus 2AB cos theta, right? So this is actually R square. So if you see, cos square theta plus sin square theta is actually 1. So this quantity is actually 1. Okay. So all we have over here will be A square plus B square plus 2AB cos theta. That will be the magnitude of R. So if you see the resultant magnitude R, that will be the magnitude. So R, this is R square. If you want R, that will be square root of this one. So if you take this magnitude of A square, magnitude of B square, and plus 2AB into cos square, that gives you the magnitude of R. Alright. Now again, if you want to get the direction component, okay, what will be the direction? Okay. Now if you want to see what is the direction of R, for that we introduce a triangle beta over here, angle beta over here with respect to the A vector. Okay. Then we look at this triangle in triangle ONS over here. Okay, we're going to look at ONS over here. We can say this final vector is because of this vector plus this vector, right? This vector is because of this vector plus this vector, right? Those two together produce the final resultant vector. Okay, so if you want to find the direction of this, then we have to make sure that we take this side of the triangle and this side of the triangle into consideration. Okay, so you want this side and this side into consideration. What would give you that particular side is that you can only use tan. Again, you can only use tan, right? So tan beta will give you perpendicular, that is SN, by base. Base is ON. This ON over here is nothing but OP plus PN, right? So the angle tan beta is nothing but, okay, ON is B sin theta by OP is A plus PN is B cos theta. Okay, so if you substitute the value for this, okay, then actually you can see that from the A vector, okay, if you find what is the beta angle, if you go that angle, okay, if let's say beta is 20 degrees, from A vector if you take 20 degrees, that would be the direction of your resultant component. Okay, this equation gives you the magnitude and this equation gives you the result, gives you the angle or the direction, because you're getting an angle with respect to A. From this vector you can say, okay, from A vector go 20 degrees or 30 degrees according to the answer you're getting, 30 degrees up, and you will actually find the direction of the resultant vector. Alright, so with this note, once again we are coming towards the end of today's class. Alright, and once again we are back with our popular offer, that is you're getting a maximum of 20% off if you're taking a plus subscription between 27th to 30th. So if the price for 1 year is again 13,800, and if you're taking a 2-year subscription, you will get around 23,000. That's the offer price, which means you're saving around 5,750 rupees if you're taking a plus subscription between 27th to 30th June. Okay, to avail this offer, you can use my code MTIS10. Once again, whenever you take your plus subscription, you're getting 4 subjects, that is math, physics, chemistry and biology. This is an ongoing batch. It started on 8 June. The mode of delivery is in English. Okay, so physics we meet every Tuesday, Thursday, Saturday between 5:15 to 6:15 p.m. Okay, and the target of this course is your midterm syllabus coverage. All of these, all of your first 5 unit in the term 5 syllabus will be covered. In the term 1 syllabus will be covered. And here you have an advantage. If you're a class 11, if you're in class 11, okay, then class 12 subscription is absolutely free. Now you can make use of this 20% off, where you can just get the course for 1 year and you can get a subscription for 2 years, right? So you're getting 4 subjects in a plus subscription. Similarly, for class 12 also, the mode of delivery is again English. This is again an ongoing batch. For physics, we meet every Monday, Wednesday, Friday between 5:15 to 6:15. The target of the syllabus, the target of this course is your midterm syllabus coverage, and we actually want to. Hi Prince, and we actually want in this course we started this early with the only idea that moving forward you will have more time for practice. Okay, so if you have any questions right now, you can ask them in the chat box. All right, and also we are introducing the community feature. Okay, and you can follow me on my community. You can go down to the description box. My community link will be given. You can actually go down to the, you can follow any of your, you can get any, you can follow your any of your favorite educator, and you will not be missing any updates from them. Okay, and you can also share your feedbacks directly via pool with the educators among if you're following them on their community. And if you go to my community, there would be actually some MCQ type questions asked from your unit 1. Okay, try attempting those. And also Bucks Bounty is one more concept where we have, in case if you come across any inappropriate content in any of the videos, okay, and if you report the same, you can claim your prize. And if you like the video, please share it among your friends, and also subscribe to the channel so you will be knowing the upcoming classes, and also click on the bell icon to get notified before your class goes live. Okay, and thank you guys. So if you have any questions, you can ask me in the chat box. Otherwise, I'll be ending the session now. Thank you, and I'll see you tomorrow for the special class at 4 p.m. on the Unacademy platform. All right.